This is Woody. Woody is a Type A Series 1 3D printer that I acquired back in 2013. Overall, Woody's been pretty reliable over the years. However, this 3D printer dates back to a time when heated beds were just not as common as they are today. In fact, Woody's controller has no accommodations for a heated bed at all. A heated bed would really increase this 3D printer's functionality by allowing me to print in filaments other than PLA. To add a heated bed to this machine means one of two things. I upgrade the controller, or I make a separately controlled heated bed. To upgrade the controller, I need to know the specific settings of the motors and the other components of this 3D printer. The problem here is that Type A machines were not open source, so the information is not readily available, and the company that manufactured Woody is no longer in business. With this in mind, I've decided to explore the option of creating a separately controlled hotbed for this 3D printer. First order of business, however, is I want to create the actual bed before I start messing with the electronics. So here's the system that was presented by WTAM69. Here is the thermostat, the temperature sensor, relay, power supply, and here's my heated bed. The thermostat works, it does work, it works pretty well. Turn it on, boots up, gives a temperature reading, and when I grab it, it starts to increase, reading my body temperature. Okay. The problem is, I discovered that there is a lag between actual temperature and what the thermostat is reading. The heated bed is now warming up. I apply the thermistor, and it is increasing to give the temperature of the bed. Unfortunately, there is a huge lag that develops between the actual temperature and what's reading. This takes a long time to catch up. Try and demonstrate here. So here we have, we're already at 65 degrees. Thermostat's reading 42. $67, reading 45, $72 degrees, reading 49, 76, reading 50, 78, 51. So by the time I reach my desired temperature on the heating pad of 100 degrees, there's going to be a significant lag. We're already up to 85 and it's only reading 55. So by the time the thermostat catches up and shuts off, it's going to be well over 100 degrees. We're now at 93 degrees and reading 60 degrees on the thermostat. So I'm predicting that if I let it go, by the time the thermostat reads 100 degrees, the heated bed is going to be, well, a lot more than 100. It is now 100. Thermostat's reading 64. Well, I'm just going to shut her off and come up with another idea. So here's the problem. I was attempting to use the thermostat sensor, this thermistor, by applying it to the glass. It doesn't give an accurate reading. What needs to happen is that I use the thermistor that is embedded within the silicone pad itself. Use it as intended. The problem that we come across here is that this is rated at 10 k ohms. The thermistor inside the glass is 100 k ohms. So that this system, if I was to plug this into here, wouldn't work. It's incompatible. 10K, 100K. So, need to figure something else out. I went back to the YouTube drawing board and I discovered this. Or rather, I discovered the YouTube channel of CNC Modeler. He's a guy who took a unit like this, or similar to this, with the same problems that this has, a 10K resistor thermistor, took the 10K thermistor, modified this system to run off of a 100K thermistor, so I can hook it up directly to the thermistor that's embedded in my heating pad. So, gonna give that a shot. So, following the example of the CNC Modeler guy, this is the input from the sensors, and right next to it is a 10K ohm resistor. Had to look up the values, put a potential or a multimeter on there, and it's a 10K ohm resistor. That little surface mount resistor needs to come out and be replaced with a 100K ohm resistor so that it will match the rating of the internal resistor of the thermistor on the heating bed. So, wish me luck. I've never replaced a surface mount resistor with a regular resistor before. This ought to be fun. Removing a surface mount resistor turned out to be surprisingly easy. Once again, I did a search on YouTube and found a channel where someone was demonstrating exactly how it's done. The channel was Curious Inventor. I'm including links to all these various channels that I'm relying upon in the description below. So I swapped out the 10K resistor on the board for a 100K ohm resistor, and it works. Allow me to demonstrate. Turn it on. It's reading 26.5, 26.6. The bed is 27.9. We're up to 30, 29.1. We're at, wait for 35. 36 degrees, 35.5. Pretty close. And this thermostat is actually tracking the heated bed temperature really nicely. It has a maximum setting of 99 degrees, at which point it goes into an overheat shutoff mode. So I've set it at 95 degrees, which is fine. I can print ABS filament on here nicely at 95 degrees. So that's what I'm going for. Works great. Very happy with it. So it's been running for about an hour now. Temperature has been very stable. No fuses have popped. Nothing is caught on fire. I think we're ready for a test print. Okay, to revisit this one, the W1209 digital thermostat for a moment. It could be modified the same way that we modified the ITC1000F digital thermostat. Here is the input from the thermistor, and right next to it is a 10K ohm resistor. The surface mount. It can be removed and replaced with a 100K ohm resistor, same way that we did the last one, the ITC1000F. It could also be made to work with this system. So I'm going to keep this as is though, because I think I have another plan for this. So doing a little test. Printing some ABS on my new heated bed. There it is, the very first part printed in ABS on my new heated bed. I am declaring Woody's new heated bed project a success. Everything seems to work just fine. I don't think it constitutes a fire hazard. Someone may disagree with me. That's fine. The one thing I am going to keep an eye on is that there is no off switch. There's no operating system that knows when the print is over and shutting it off. So maybe those overnight prints are gonna be fewer and far between. This one requires a little bit of babysitting, but that's fine.